Hi, my name is Tiara, and today I'm going to discuss with you the three primary states of data. I'm also going to discuss how you can secure data in each state, as well as security strategies for each state. The three primary states of data is going to be data at rest, data in use, and data in transit. Data at rest refers to information that is being stored on a device or medium, such as files on a laptop device, records in a database, or backups in cloud storage. Data in use is information that is actively being processed in memory by applications or information that is actively being processed by individuals. This can include an employee updating or modifying a confidential document at their workstation, or a payroll system calculating wages. So that's going to be your data in use. Data in transit consists of information that is moving between systems or networks. This can include emails crossing the internet or an API call between a mobile app and a server. So that's your data at rest, data in use, and data in transit. How do we secure these different states of data? Securing data at rest. Securing data when it's not actively being used involves encryption, controlling access, as well as physical safety measures. Full disk encryption is going to help safeguard devices if they are lost or stolen, while encrypting databases or files is going to reduce the risk if data storage is copied. Role-based access control and applying the principle of least privilege is going to minimize who can access sensitive data. And then physical measures like locking server rooms, using badge accesses, or securely disposing of drives is going to prevent direct access to data. How do we secure data in use? It's hard, some people would say, to protect data in use because information has to be open. It has to be accessible to applications, right? So traditional means here is going to be ineffective. So what we would use here is we would use strong authentication and session controls. These are going to help to decrease the likelihood of both credential theft as well as user impersonation. Multi-factor authentication, that's going to be helpful for critical accounts. Continuous monitoring, adhering to various security standards can also help identify the misuse of data, such as endpoints, system logs, alerts for suspicious activity. These are all going to be helpful. The principle of data separation and privileged access management after the authentication process is going to prevent users from being able to perform certain actions while they're processing data. So all of these is going to help secure data in use. Now let's move to data in transit. The goal here is really to prevent eavesdropping as well as tampering over uncontrolled networks. So here we would use SSL or TLS, which is going to offer data encryption for web and API traffic. It can also support the integrity checks against interceptions and manipulation. VPNs are going to be important here. Those are going to provide encryption for remote access connections, which is often used to secure public Wi-Fi access. Standard transport encryption practices are going to ensure strong default cipher suites, validate certificates, we want to implement modern security protocols. Really just going beyond simply requiring HTTPS, right? Network threats can include attempts to degrade security measures and rogue access points. So to counter this, it's essential that we change out keys on a regular. We replace certificates, update protocol behaviors, and then also that we manage certificates safely. So these practices are not going to be a set it and forget it type of thing. It's going to be constant attention and engagement for data in transit. Security strategies are going to vary between the data states, as we've mentioned, right? Data at rest, data at use, in use, and data in transit are all unique controls because they all have unique or different vulnerabilities, right? So how we deal with one is going to be different how we deal with the other. uh Data at rest, their vulnerabilities is going to include threats that such as stolen disk or misconfigured storage. So as we mentioned above, the strong encryption is key here. Key management, backups, physical security is going to be essential for data at rest. However, data in use, our focus here is preventing improper access. So this is where we're going to have that strong authentication, the least privilege authorization, the session monitoring. These are going to be helpful. Encryption is useful here, but key handling and endpoint trust is more crucial. And then for data in transit, our main goal here for data in transit is to reduce the risk of interception. So what we talked about earlier, where we require the use of TLS or VPNs or certificate validation, these are all going to help with aligning our goals for confidentiality and integrity. So again, we have three primary states. It's going to be data at rest, data in use, and data in transit. There is no one size fit all solution that's going to fit every state of data. So it's very important that we know what state data is in so that we can better help to secure data and safeguard it.